Good day everybody, we've been given a beautiful question. I'm going to draw the figure. I'm going to make an attempt. If I'm not, I will have to redraw it again. So, got a circle. Now, there is a semicircle that is actually hitting the circle Okay, I have got the figure. Now this is the center for the circle and this is a semicircle. Okay, now this is the center and this is also a semicircle and this is the center. Okay, now let me take this point as AB. Now AB is given. Okay, let me write that down. The value for AB is 12 units and I'm going to take this as CD. The value of CD is 8 units and we are asked to find the radius of the small circle. Small circle radius has to be found. Okay, so these are the information that are being given. Now I'm going to take this point as O. If I take this point as O, then OA is equal to OB is equal to 6 units. So this distance is going to be 6 units and this distance is going to be 6 units. Okay, fair enough. Now what I wish to do is I would like to actually connect this point with this point and this point with this point. So step number 1, let me draw OD and OC. Now OB is the radius. Now OD will also be the radius, right, of the big semicircle. This is drawn and this is drawn. Okay, now this means OD is equal to OC is equal to 6 units. So this length and this length are one and the same. So this would mean triangle DOC is isosceles, right? Is it clear? That's going to be an isosceles triangle. Now if this is isosceles, then as I mentioned to you, if I were to draw a line from the top index, from this index, from the top vertex to the center, then it would divide the base into equal parts. Now I know CD is 8 units, so this is going to be 4 units. This is going to be 4 units. Okay, fair enough. Now this perpendicular, this line which I have drawn is a perpendicular bisector. That means it will divide this angle here into 2 equal parts and it is making an angle of 90 degrees. So we have a 90 degree there. Okay, so what I'm going to do is consider triangle C. Let me take this point as P. C P O. by Pythagoras. Why I'm using Pythagoras? Because it's 90 degree. So by Pythagoras, the great Pythagoras theorem. So what do we have by this theorem? Cp squared plus OP squared is equal to OC squared. Okay, this is the hypotenuse. Now, do I have OP squared? No, I don't have OP squared. I just take it as OP squared. Do I have CP squared? OC squared? OC squared is 6 units. 6 squared. CP squared? 4 squared. So OP squared is equal to 36 negative 16, which is 20. So OP is equal to root of 20, which is nothing but root of 4 into 5, which is equal to 2 times root of 5. This is my OP. So I've got OP. So let me write that down. 2 times root of 5 OP. Now what I wish to do is I would like to drop a perpendicular from this point to the base. Okay, can I do that? Now let me do that. Now this is the center of the semicircle. From the center of the semicircle I am dropping a perpendicular. A perpendicular is dropped, so that is going to be making an angle of 90 degree. I know this value. Now this is from the center of the semicircle, from the center to the point on the circle, or I should say point on the semicircle. I know the radius 4 units, so this is going to be 4 units. So if this is known, I can always find, say, R. I can always find R. Now you may be wondering, why am I looking for R? Now there is a reason for that. So let me work it out here. Okay, consider, okay, this is step 2, step 1, step 3. So consider O, triangle ORP. Okay, so if I were to consider triangle ORP by Pythagoras theorem, what do we get? OR squared plus RP squared is OP squared. OP squared is 2 into root 5 squared. RP squared 4 squared. OR squared, I don't know. So this is going to be 4 into 5 negative 16, 20 negative 16, which is 4. Therefore OR is equal to 2 units. So OR is 2 units. Just write that down there, 2 units. Okay, I've got that value there. Now what I'm going to do, I'm going to drop a perpendicular from the center of the small circle to the point, or I should say to the diameter AB. So let me drop that. So this is dropped. Now I'm going to name this as C1 and I'm going to name it as S. Now C1S and P and R, they are parallel because of the fact that these two are perpendiculars dropped and they are all on the same line. They are on the same. If I were to draw a line here, that would actually be parallel to SR. Okay, so I'm going to take this as R, right? So now the question is, how am I going to find the value of R? I know this distance, so let me take this distance as some x. So this total distance is x plus 2. Now I need this distance. Now you might be asking me why I need this distance. there is a reason for that, why I need this distance. Now what I'm going to do is I'm going to draw a line. I'm going to draw a line connecting this center with the center. Okay, I'm going to draw a line connecting the centers. Now it is imperative to understand, now there is a point of contact here. Okay, now if I were to draw a line via the point of contact, then that line would actually connect the centers. So there is a connection here and there is a connection here. So the centers are connected. Why is it connected? Because I have drawn a line via the point of contact of the circles, two circles. Okay, now this is a perpendicular, so this is 90 degree. Okay, and now I want to express x in terms of r. Now this total distance is going to be the radius of the biggest circle, and that is going to be 6. This entire thing is going to be 6. This distance is r. From 6 I'm going to take away r, so this is going to be 6 minus r. Okay, fair enough. Now I did all these things so that I'm able to express x in terms of r. Now this is a right triangle, so let me go to that point. Okay, let me go to the point of consider triangle C1SO by Pythagoras theorem. What do we get? We get C1S squared plus OS squared is equal to OC1 squared. OC1 squared is 6 negative r raised to the power of 2. OS squared is x squared, and C1S squared is r squared. So you expand this, you get 36 minus 12 times r plus r squared, x squared plus r squared. This and this can be cancelled. So you have 36 negative 12 times r is equal to x squared. So x is going to be root of this. This is the value. I need this value. Okay, fine. Now what I'm going to do is, I've got a nice figure forming. I got a triangle, then I can make another triangle here. Now this is the center here. I can make another triangle here. Okay, so a triangle is being made. Now if you were to see here, a triangle, so you are actually seeing a trapezium. Clearly SRPC1 is a trapezium. Okay, so since I have a trapezium, what I'm going to do is I am going to, so this is a base and this is a base, right? Two bases are there, so I can easily connect, or I should say drop a perpendicular from this center to the line PR. Okay, that's exactly what I'm going to do. Now if I were to do that, then that would hit an angle, that would make an angle of 90 degree here. Now I need that. Now why do I need that? You will know in a minute. Okay, so this entire length, we know this entire length, right? It's 4 units, and if this is r, this should be r. So we are looking for this measurement, so that's going to be 4 negative r, because this and this are one and the same. Okay, so this is going to be 4 minus r, and this entire length is going to be x positive 2. So this is going to be x positive 2. So I got this, and what is this? From here to here it's going to be 4 units, and from here to here this is going to be r units. So this entire length is going to be 4 plus r units, right? So you have a system that is being formed there. Now we have to evaluate that system. That's it. That would be the solution. So what I'm going to do is, let me consider let me write this down here. Consider triangle C1. I'm going to take it as QP by Pythagoras. So by Pythagoras, what do you get? You get C1Q squared positive QP squared is equal to C1P squared. C1P squared is 4 plus R raised to the power of 2, and the QP squared is 4 negative R raised to the power of 2, and C1Q is x positive 2 raised to the power of 2. Okay, now x is this value, so we need to substitute that value there, and that would have to be squared. Okay, so first let me evaluate these two. This is going to be 16 negative 8r plus r squared is equal to 16 positive 8r positive r squared. So this and this can be cancelled. This is just 16, so 16 and 16 can be cancelled, and you get x positive 2 raised to the power of 2 is equal to 8 plus 8r plus 8r. That is going to be 16r is x positive 2 raised to the power of 2. So this is what you've got, right? Now what you got to do, you take the square out to the other side. So this is going to be root of 16r is equal to x positive 2. Now take the value of x and substitute here. So this is going to be root of 36 negative 12r is equal to 4 times root of r minus 2. So this is what we have got, neat. Now you square both sides. Okay, if you square both sides, you get 16r negative 8 times 2 is 16, and you got a root of r plus you got a 4 there, and when you square this, the root and the square they get neutralized, so you get 36 negative 12 times r. Now what you can do is you can move this to the other side. So you are getting a value, you are getting a fairly manageable value. So this is going to be 16 and 8 and 28 r, and then negative 16 root of r, and then if I were to push this to that side, you get 36 negative 4, which is nothing but 32 is equal to 28r negative 16 into root r. Now this is what I've got. Now I need to solve it. Now solving this, we have to solve it by moving this to the by moving this component to this side. That's because we have to get rid of that root. So 32. Okay, now I will do it in this fashion. I will take 28r negative 32 on this side. Okay, so let me use this part of the page. So what I'm going to do, I'm going to move this guy 16 root of r to this end, and I will keep 28r negative 32 like this. Now I square both sides. I don't want this root of r. Now if you square that, you get 28r raised to the power of 2 negative 2 times 28r times 32. In fact, we could have reduced this. It would have been much better. Okay, we would have had a smaller number. So what I want to do, before I could square it, let me reduce it. This is 16 into root of r is equal to 28r negative 32. So I will use divide by 4. So this is 4 into root r is equal to 7r negative 8 4s are 32, right? So divide by 4. So that's fine. So now I square it. So I get 7 squared 49r, 7 times 8 56, 6 2s are 12, 5 2s are 10, 11, 56 into 2, 6 2s are 12, 1, 5 2s are 10, 11 r positive 64. On this end I get 16 into r, so that's fine. Now this is r squared, so we are getting a quadratic. So 49r squared negative 112r and followed by negative 16r positive 64 is equal to 0. Now you add this, you get 8 and 2 and 1 negative and positive 64 is equal to 0 and 49r squared. Now we are doing all this thing to get the radius of the small circle. Okay, this is what we got. 7. We can't reduce anything further, so we have to apply quadratic. So if I have to apply quadratic, I would get negative 128 plus or minus root of b squared. So 128 squared negative 4 times a times c divided by 2 times 49. So this is what we have got. Now we have to simplify this. So simplification is critical. So let's get a calculator. So I have a calculator here. I'm going to take 128 squared plus or minus, what is that? That gives me 16384 minus 4 into 49 into 64. That's 12544. You get 128 there divided by 98. So 16384 minus 12544. You get this to be as root of plus or minus root of 3840. This is 128 divided by 98. So I'm taking square root of 3840. What is that? That is giving me 128 plus or minus 16 into root 15. That's a lovely value divided by 98. Okay, so 16, is there any, can I reduce it? Okay, I can rewrite this. I'm going to rewrite this value as 4 times 4 3s are 12, 4 times 2 plus or minus 4 squared root of 15 divided by 98. So I can take 4 out. I would get 32 plus 4 into root 15 divided by 98. That's the utmost I can get. Now I'm going to take the positive end, because negative end will give me a lesser value which will contradict the question. So positive value alone I need. So there's going to be 4 of 32 positive root of 4 times root of 15 divided by 98. So I use 2 4s are 8, 2 9s. Now I get 2 over 49 times 32 plus, I'm going to use my calculator and find out the value of root of 15, and I multiply it with 4. I get 15.49. To it I add 32. I get 2 over 49 times 47.49. I multiply it by 2 and I get 94.984 divided by 49. I will divide this by 49, and that is approximately 1.94. This is the radius, right? This is the radius. Now this alone is not enough. Why I'm saying this alone is not enough? Because of the fact that we need to find the area of the region excluding the small circle. Okay, so required area, let me write that down. Required area is equal to area of the large circle. That's going to be pi into radius is 6 units. So pi r squared and we are dealing with a semicircle. Okay, so the area of the semicircle means we have to divide by 2. This is the area of the semicircle. From the area of the semicircle, we subtract the area of the circle, 1.94 squared. So this is equal to 18 pi minus pi times of 1.94 squared. I take pi out, I get 18 negative 1.94 squared. So 1.94 squared, that is 3.7636. Okay, and that is going to be pi times of 14.24. So the required area is 14.24 pi square units. Okay, this is the required area. So how to get the required area? Required area is nothing but area of the entire semicircle. So pi r squared is the area of the circle, but you divide by 2 because of the fact it's a semicircle. So you get 18 pi minus area of this circle. This is pi r squared and the radius is 1.94. So I place 1.94. I take the pi out, 18 negative square of this, you subtract it, you get this value, and that would be the area of the region, taking away the area of the circle. So this is a lovely question. Please like, share and subscribe to the channel. Until we meet again, enjoy your day. Thank you.